Hello, and welcome to Mr. Ambrose's video on Qsfr and how we use that to calculate exact values of trig functions. Hopefully the gift that the sub gave to you today in class helped you understand the basic premise here, and this video is going to actually just go through the examples at the end of that gift. So let's get to it. The first example asks you to find the exact value for the cosine of 240. So using the acronym of Qsfr, right, we can just put that down here. Qsfr, right? This just organizes ourselves to be able to calculate this exact value. So Q stands for quadrant. So the angle of 240 degrees we know terminates in quadrant number 3. From this here, we go on to the next letter in the acronym, which is S, and this stands for sine. But it's not the sine function, it's sine as in positive or negative. Is the cosine function positive or negative in quadrant 3? Well, since remember that cosine is the same as the x-coordinate of our point on the unit circle, in quadrant 3, x-coordinates are negative, so cosine will be negative in quadrant 3. The F in Qsfr stands for function, and basically whatever you kind of start off with, that's really going to be your function. This Qsfr is just, again, a way to organize how we can write out or how we get to our final answer. So F will be cosine. And R stands for reference angle, and hopefully you were able to set up formulas to calculate reference angles in different quadrants. Since we're in quadrant 3, our original angle is 240. We would calculate the reference angle by taking 240 and subtracting 180 from it. And we would get 60 degrees. Right. So now we can take the cosine of 240 and we can rewrite it as the negative cosine of 60 degrees. Right. That's what the Qsfr does. It breaks down the trig expression you might have into another expression where your angle here is going to be an angle in the first quadrant. And as I mentioned earlier last week, you are going to have those exact values memorized. So we know the cosine of 60 is equal to 1/2. So our final answer, the exact value of cosine of 240 degrees, is that it's equal to negative 1/2. All right, so let's go on to the next example. Next example here, we have to evaluate the tangent of 3 pi over 4. So I'll once again set up my Qsfr. You're going to have to start to get yourself more comfortable with and acclimated with radian measure. So 3 pi over 4 is an angle that terminates in quadrant 2. Right. So now for the sine of tangent in that second quadrant, hopefully you were able to get this on the gift on the prior page, but tangent is going to be negative. In particular, you can get that because we know in second quadrant, sine is going to be positive, cosine is going to be negative, and since tangent is the same as sine over cosine, a positive divided by a negative should end up being a negative value. So tangent is negative in quadrant 2. The function, as I mentioned earlier, is going to be the same function that you're working with to begin with. So since we have tangent here, our function will be tangent. And for our reference angle, since 3 pi over 4 is in quadrant 2, the reference angle calculation would be pi minus 3 pi over 4 to get our reference angle. And to help do this calculation, I would make pi into a fraction, and not only a fraction, but a fraction with the same denominator as 3 pi over 4, and that would be 4 pi over 4. So 4 pi over 4 minus 3 pi over 4 gives us a reference angle of pi over 4. And with that, we can now rewrite the tangent of 3 pi over 4. That should be equal to negative tangent of our reference angle of pi over 4. And the tangent of pi over 4, again, that's an exact value you have to have memorized. Tangent of pi over 4 is just 1. So our final answer would be, to the exact value for tangent of 3 pi over 4, it'll be equal to -1. All right, next problem. We are asked to calculate the sine of 120. So I'll set up my Qsfr. The 120-degree measure terminates in quadrant 2. The sign of sine in quadrant 2 is that it's positive in that quadrant. Our function, again, that's the same as what we're starting off with, so that's sine. And the reference angle to 120 degrees, well, again, I'm in quadrant 2, so I take 180 degrees, and I subtract 120 from that to get my reference angle of 60 degrees. So we can rewrite the sine of 120 as positive sine of 60 degrees. Sine of 60 being an exact value that we know of, but you have to have memorized. We know that that's equal to the square root of 3 over 2. And again, this end result has to be positive, so the sine of 120 degrees is equal to positive square root 3 over 2. All right, so moving along, our last problem here, we're asked to find the exact value for the secant of 5 pi over 3. The hint on the gift was to think of what is the reciprocal value. Well, since secant is the reciprocal of cosecant, I'm actually going to find the exact value, or cosine, I'm sorry. I'm going to find the exact value for cosine of 5 pi over 3, right? Sorry, secant is the reciprocal of cosine. I'm going to find this exact value, and then once I have that, I can quickly calculate what my secant of 5 pi over 3 is, right? So quadrant, 5 pi over 3 is a radian angle measure that terminates in quadrant 4. The sign of cosine in our fourth quadrant is that it's positive in the fourth quadrant. Our function, I'm going to deal with this cosine function, so I'm going to label it as cosine, and my reference angle. All right, I'm in quadrant 4, so my reference angle will be calculated as 2 pi minus 5 pi over 3. And as I did in the prior problem with the radian angle measure, I will make 2 pi into a fraction, but specifically a fraction with a denominator of 3. So that would be equivalent to 6 pi over 3. And we'll subtract that from 5 pi over, or subtract 5 pi over 3 from that. And 6 pi over 3 minus 5 pi over 3 gives us 1 pi over 3. So now we can rewrite the cosine of 5 pi over 3 as positive cosine of pi over 3. Cosine of pi over 3 is an exact value. Again, you need to have memorized. Cosine of pi over 3 is just equal to 1/2. So this will be positive 1/2. And so that's what the cosine of 5 pi over 3 is. It's positive 1/2. So since secant is the reciprocal of cosine, the reciprocal of 1/2 is just 2. So the final answer to this problem, that the secant of 5 pi over 3 is just equal to 2. So hopefully this video helped with your understanding of how we can use Qsfr to find exact values of trig functions. And I hope you have a good night, and I will see you guys tomorrow. Take care.